K nearest neighbor, also abbreviated as KNN, is also called the lazy learner algorithm because it doesn't learn, or rather doesn't apply a discriminative function from the training data. Instead, it just memorizes the training data, right? Meaning that it just kind of just immediately stores the data set and uses classification, or rather it performs an action on the data set during classification. Now, by definition, it's also non-parametric. Non-parametric just means it doesn't make any assumptions on the underlying data. And also it's instant-based algorithm that's used for both regression and classification problems. So the K here in the nearest neighbor is just a parameter that refers to the number of nearest neighbors, right? To include the majority of the voting process. So let's briefly look at how to, how actually this algorithm works. So suppose we have the following, two classes, A and B. A here represented by red stars and B represented by green triangles, right? So let's say in our case here, we want to introduce a new example to classify. First of all, we have to, specify how many nearest neighbors are we going to use to do majority voting. So here in our case is 3. So here we're saying we have to use 3. So if we introduce a new example here, I can already see we have 2 green triangles and 1 red star. So based on this, we can already know the majority here is green. So based on this, we can see that we can safely say or classify this as also a triangle, right? So another thing to note here is that KNN here kind of uses feature similarity. This similarity is computed by some distance metrics like Euclidean distance, right? Which is just the square differences, on a straight line. Again, this is just based on a similarity distance. Okay, now finding K isn't very easy because you have to find that value, right? So you have to choose different values, and this is what we call parameter tuning. Okay, this helps to improve the algorithm accuracy. So one of the advantages of using K nearest neighbor is that it's very easy to implement, very robust to noisy training data, and very efficient or very effective when training on very large data set. Okay, now let's look at the implementation in Python. But first, let's look at the API reference here from sklearn. So we go here, we can see that it comes from this library. Sklearn comes from this module neighbors. So click, then we can see we have quite a bit here, right? But in our case here, we just interested in, so we are interested in importing the K neighbors classifier, right, for classification. So this is the one we are interested in. So if you click on that, has some documentation of what parameters here. So you see how many neighbors. By default, it's actually 5. Again, most of these things will just leave us default, but we can tune some of these parameters to improve the performance of this classifier. So going back here, we import these 3 libraries like before. Again, here, pandas for importing the data frame or data set. The model selection module for train test split. Classify here, KNN, and also confusion matrix, right? We split our data again. We instantiate our classifier here. This is the only thing that changes here. So here, actually, this is not logistic. This is KNN, right? Model on the training data. Okay, so we do that, and then we fit it, right? We fit this on our training and test training and our white train as well. We predict that. Again, we can go ahead and run this. So what we are paying attention to here is the recall. So again, it's just 50%. So not doing very good. We are losing, or we are missing 50% from our data, right? So you can see out of the 54 patients, right? we were able to correctly identify only 50%, all right, 54%, 54 support. Okay, so again here, KNN doesn't, memorize the data, it actually just memorize the data, so it doesn't do discrimination. So this is actually good where you're making some categories. So for example here, let's say, you want to distinguish between, rather you want to classify whether, a new example is a cat or a dog, right? So based on this, let's say our nearest neighbor here is 1, 2, 3, 4, 5. So our K equals to 5. So with a new training example here, a new data point. So based on similarity, this one looks more closely to a cat, maybe, all right? Or maybe based on this majority voting. So that's how KNN kind of works. Okay. All right, that's it. And lastly, we're going to be looking at perceptron.